Hey, good morning. We're going to look at E7. So E7 is to find the distance between a point and a line. So line L has an equation of y equals -1, and you're going to find the distance between L and point C, -3, 3. So all you're doing is counting the spaces. So what you're going to do is go to desmos.com for this one and select graphing calculator, and then we're just going to enter in our point and our equation. So we're going to enter in the equation of y equals -1. So I go y equals -1, and then it creates that red line. And then next I'm going to enter my point. So I use parentheses, -3, 3. Close my parentheses. I want to go ahead and label that. So now that we have all that information there, let's expand this. So all you're doing is counting the spaces between the red line and the blue point. Make sure everyone can see that. So the red line is at -1 and the point is at -3. So we're going to count the y spaces. So I go 1, 2, 3, 4. My answer is going to be 4. The reason why it's on a -4 is because when we count distance is always positive. Okay, so the next one, we have y equals 5. So that's y equals 5. And then my ordered pair is going to be h's. Find the distance between line L and point H, -1, 3. So -1, 3. And we have that on our graph. So if we count the distance, we have 3, 4, 5. So my distance is going to be 2. Okay, and then it says line L has the equation at x equals 2. So we're going to use x equals 2. And then find the distance between L and the point V, 3, -4. So, oh, I have some typos here. Okay. So x equals 2. We're going to label that. And then our point is 3, -4. We're going to label that. Let's see where it shows up on our graph. So I have the line, but where's the point? Okay. And then we're going to count the spaces. So from 2 to 3, the space is 1. Okay, next one. Y equals -7. Delete that all the way. Sorry about that. So if you want to clear it, you can just exit out. So y equals -7. And then our point is going to be 6, 2. We're going to label that. And on our graph, let's see. So we count the spaces. My spaces are going to be from -7 all the way to 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So answer is 9. We're counting the vertical spaces. Okay, same thing for this one. Y equals, y equals 2. And then our point is going to be -5, -4. Oh, that goes on the second line, sorry. -5, -4. I'm going to label that. Okay, and the difference of spaces is going to be, it's supposed to be y equals 2, not -2. Sorry about that. It looked incorrect. So when I expand it, I'm going to get 4, 5, 6. So the difference is 6. Okay, keep on working. So that is basically how you solve for E7. You do need to know the point slope formula for the next set of equations, but that's pretty much it. And that's going to be another video altogether, unless we get to this one when we get to like, we're working towards like an 80. And we're using Desmos.com. Again, if you're not familiar with Desmos.com, it's pretty much the calculator that you should be using on campus. It's the easiest to use at this point. All right, so let's find our graph. So this is a vertical graph, so we're looking at what's happening on going across from left to right. So the difference between x equals 0, so that's right on the y-axis, and 1 comma 2, my distance is going to be a difference of 1. Keep on. So this one is going to be y equals 4. And then this one's going to be 4 comma negative 3. Enter. We want to label that. So think about it. The distance between 4 and negative 3 is 7. So I say 4. So I count down 4, and then I add 3. So the difference is 7. All right, so this is going to be a longer one. You definitely need to know how to find the perpendicular line. So let's look at our points, and then let's talk about our line. So our line is going to be y equals x plus 1. And our point is going to be 2 comma negative 5. Right? So what you basically want to do is you want to create a perpendicular line for the intersection of 2 points, and then use the distance formula to find those points. So I know that my perpendicular line is going to be a negative slope, so it's going to be negative 1x. And then I want it to cross through that point of 2, negative 5. I already know the formula, so I'm going to actually give you the formula. Excuse me. So it's been negative 3. So that's the formula, and then you count the distance for the perpendicular. So let's figure out how to get this information. All right, so getting back to this equation, the first thing you need to know is the slope-intercept form. And basically, y equals mx plus b. X and y are numbers, so it's an ordered pair. And then m is the slope and b is the y-intercept. And then you need to know the definition of perpendicular lines. So the definition of perpendicular lines is as follows. Basically, all you're going to say is we know that the slopes of perpendicular lines are lines that cross and lines that have slopes that are negative reciprocals. So what I mean by negative reciprocals is that we have this slope right here of, let's say, m. And so the slope of the perpendicular line, so this is y equals mx plus b. So the slope of the perpendicular line is going to be a negative slope and the reciprocal. So that's going to be the second line. And that's what we need to determine from the equation that's given to us. So we know that we have, let's see, what do we know? We know that we have the equation y equals x plus 1 and the point 2, negative 5. So with that in mind, I know that I want to go ahead and talk about my reciprocal slope and how to find the new line and the new point. So to do that, I'm just going to change some stuff up here. Sorry. So my original line is y equals x plus 1, and I want my perpendicular line equation is what I'm looking for. So already I know that I have points Q, which is 2 comma negative 5. But if we think about it, this is actually the x and a y. So x equals 2 and y equals negative 5. So I know that my slope here, my slope for my perpendicular line, since this slope is 1, I know that my slope of my perpendicular line is going to be negative 1, right? Because this is m equals 1 over 1. So slope of my perpendicular is going to be the flip, so it's negative 1 over 1, which is just equal to negative 1. So if I substitute that in, I get negative 1, and then I go back to my x plus b. What's good about this is that now that I know my perpendicular slope, I can now substitute my y, my x and my y into this equation and then solve for b. So right here, I'm going to solve for b. So let's give us some space. I know that I was going to say that y equals negative 5 equals negative 1 times 2 plus b. That's b as in boy. So I get negative 5 equals negative 2 plus b. I have to get b by itself, so I'm adding 2 to both sides. So I have negative 3 equals b. So from all of this, I now have my new equation. My new equation, I'm going to talk about the parts that I'm going to highlight for my new equation. And the parts I'm going to use for my new equation are going to be the b, my perpendicular slope, right, which is negative 1. And then we're going to use the slope-intercept form to make it. So I get the line of my perpendicular line is going to be negative 1 x minus 3. So then that's going to give us our new point. Let's talk about that. Excuse me. So we go into Desmos. We're going to type in our equation, y equals negative 1 plus 3. And now it's going to give us the point of intersection. So this was my new point. I labeled it, and now I'm going to have a second point. The second point that I'm going to be looking at, and I just want to label it, is going to be negative 2, negative 1, because that's where our line crosses and makes and becomes perpendicular. So then let's go ahead and add that. And I had negative 2 comma negative 1. We're going to label it, and we're trying to find the distance between those 2 points. So now we're going to use the distance formula. Okay, so let's move up our page. So here is our information. My original point is 2 comma negative 5. My perpendicular point is going to be negative 2 comma 1 or negative 1. And our distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So then we're going to substitute. I know that my x1 is 2, y1 is negative 5. X2 is negative 2, and y2 is negative 1. I'm going to create my inequality or my square root. I'm going to substitute those numbers in. So then I get -2 minus 2, -1 minus -5. I keep on simplifying. You can just do this in a calculator if it's easier for you or more convenient. So I get -4 squared. Whenever I have these two negatives together, I get -1 plus 5. So as I continue on, I'm going to get 16 plus 4 squared, square root of 32. And then that's equivalent to approximately 5.65. And when I estimate that, I get 5.7. And that's my answer in IXL, because I want to round my answer to the nearest tenths. Okay, I'm going to do it again. Here's the second one. It says line L has the equation of y equals x minus 5. Find the distance between L and the point H, 4, -3. So let's go from there. So I have 4, -3. That's my x and my y. And my slope for y equals x minus 5. My m is going to be 1/1. So that means my perpendicular slope is going to be the opposite reciprocal. So the first thing you need to know is that x equals 4 and y equals -3. And we're trying to find the line of the perpendicular line equation. So I know that m equals 1 for the first line. And to find the opposite reciprocal, my perpendicular slope is going to be -1. And then I'm going to substitute the x and the y into the equation. So let's go ahead and do that. So now we're going to say that we're going to say that -3 equals -1 times x, which is 4, plus b. So we're going to solve for b. So then I get -3 equals -4 plus b. Add 4 to both sides to get b by itself. So b equals 1. Again, this is my y-intercept. So that means my perpendicular equation is going to be y equals -1 x plus 1. So what I'm going to graph is line L, the point, and the perpendicular line, so that I can get my point of intersection so that I can find my distance. So I go to Desmos. I've already graphed the first two. Now that I have my line equation, y equals -x plus 1, I look for the point of intersection, and the point of intersection is already labeled. I did that ahead, and it's 3, -2. So I need my 3, -2. So I need the first equation, or the first point, which was 4, -3, and 3, -2 to work on my distance formula. So my distance formula is going to be d equals x2 minus x1 squared plus y2 minus y1 squared. Okay, so just so you know, to substitute, x1 equals 4, y1 equals -3, x2 equals +3, and y2 equals -2. Yeah, so we need to find the distance. So I get equals the square root 3 minus 4 squared plus -2 minus -3 squared. And I'm just simplifying in the parentheses underneath the square root. So I get -1 squared plus, remember that this becomes, sorry, it's my animal. Remember that this becomes a positive. Two negatives next to each other becomes a positive. So I end up getting a 1 there as well. So it becomes 1 squared. So then I get 1 plus 1, which equals 2. And so as a decimal, I'm going to get 1.4, I believe. It gets 1.4, which is the equivalent of the square root of 2. So let's see what happens when I put that in the ith cell. 1.4. All right, I'm at a 75 and I have one more left. Okay, so we're going to have that y equals -x, and our point is going to be -6, 3, and we want to find the distance between that point and the line. So we need to find the slope here. So the slope here is going to be m equals -1, because that's a -1 in front of the x, right? And then I want to find my perpendicular slope. Another thing we need to know is that x is going to be -6 and y is going to equal 3. So I know that my perpendicular slope is going to be the opposite reciprocal. So this is -1/1, again, which is equal to -1. So it's going to be a positive 1/1, which is just equal to 1. So I need to find my perpendicular equation. So I say y, so we're using y equals mx plus b. And again, we know that this is my x, this is my y, and this is my perpendicular slope. And right here, we're trying to solve for b. So I'm going to say 3 equals 1 times -6 plus b as in boy. 3 equals -6 plus b. I'm solving for b, so I'm going to add 6 to both sides. So b equals 9. So that makes my perpendicular equation is going to be equal to 1x plus 9. So then I need to find my second point so that I can use my distance formula. And remember that your distance formula is going to be, it's going to be d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so let's see what this looks like in Desmos. So we plotted the initial point of -6, 3. That's what's labeled. And then we plotted the line y equals -x. And then we plot the perpendicular line, just so you can see it, of 1x plus 9. And then that's when we got the point of intersection. So the point of intersection right here is going to be -4, comma 4.5. So those are the points I'm going to use for my distance formula. All right, so let's talk about this. The point that we got was -4.5, comma 4.5. And then our second point is -6, comma 3. So x1 equals -6, y1 equals 3, x2 equals -4.5, and y2 equals 4.5. Okay. I need more space. That's 4.5. So equals, we work underneath the square root first. -4.5 minus 6 squared plus, that's y1, 4.5 minus 3 squared. As I simplify, we're working underneath the square root. Remember that these two negatives become a positive, so I get 1.5 squared plus 1.5 squared. Continue to work underneath the square root. So 1.5 times 1.5, or 1.5 squared, is going to equal 2.25. That's a total of 4.5. So if I take the square root of 4.5, I get approximately 2.1. So my distance is equivalent to 2.1. And that's my answer. All right, we're at an 80 or a 79. I'm going to go ahead and stop there. See you in class.